The breakdown voltage of a Zener diode is very sensitive to the temperature of operation. If we change the temperature, the breakdown voltage will also change. The temperature coefficient Tc can be used to find the change in Zener voltage due to change in temperature. Tc is equal to delta Vz divided by Vz divided by T1 minus T0 multiplied by 100% per degree Celsius. This is the formula for Tc, and I will use this formula to solve one numerical problem. First we will see the terms involved in this formula. Delta Vz is the change in Zener voltage, change in Zener voltage. Vz is Zener potential or Zener voltage at 25 degrees Celsius. Zener voltage at 25 degrees Celsius. 25 degrees Celsius is the room temperature. So Vz is the Zener voltage at room temperature. T1 temperature T1 is the new temperature, and temperature T0 is the room temperature, that is 25 degrees Celsius. And if we have these things, we can easily calculate the temperature coefficient, or we can calculate the change in Zener voltage if we have the temperature coefficient. Let's move to the numerical problem. In this numerical problem, we have to calculate the change in Zener voltage, that is delta Vz. We have to calculate delta Vz. If Zener voltage is equal to 10 volts, Vz is equal to 10 volts at 25 degrees Celsius. Vz is the Zener voltage at 25 degrees Celsius, and the new temperature is 100 degrees Celsius. New temperature, it means value of T1 is equal to 100 degrees Celsius. T1 is equal to 100 degrees Celsius, and temperature coefficient is 0.072% per degree Celsius. Tc is equal to 0.072% per degree Celsius. T0 is equal to 25 degrees Celsius, and there is no need to convert these temperatures to Kelvin because we have to calculate the difference between let me show you the difference between the two temperatures. So there is no need to convert them to Kelvin because the difference remains the same. Now I will use the above formula to calculate delta Vz. Tc is equal to delta Vz by Vz divided by T1 minus T0 multiplied by 100% per degree Celsius. We have to calculate delta Vz, so I will rearrange this formula, and we have delta Vz equal to Tc multiplied by Vz divided by 100%. In bracket we have T1 minus T0. Let's try to calculate delta Vz. Tc is equal to 0.072% per degree Celsius multiplied by 10 volts. I will put them in brackets, multiplied by 10 volts divided by 100%, and here we have 100 degrees Celsius minus 25 degrees Celsius. And when you solve this, you will find delta Vz is equal to 0.54 volts. So this is the answer, and the new Zener potential is equal to Vz plus delta Vz. Vz is 10 volts, delta Vz is 0.54 volts. So the new Zener potential is equal to 10.54 volts. So on increasing the temperature, Zener potential increases. For 25 degrees Celsius, we had 10 volts as the value of Zener potential, and for 100 degrees Celsius, we have 10.54 volts as the value of Zener potential, and there is significant change when we increase the temperature.